3 days ago, a team of astronomers quietly submitted a paper to one of the most respected journals on Earth. And when other scientists read it, the reaction was not excitement, it was dread. Because buried in that paper is a single object that should not exist. An object shining 100 billion times brighter than physics says any star is allowed to shine. An object that is somehow a black hole and something that looks like a star at the exact same time. And the researchers who found it are not celebrating. They are quietly hoping they made a mistake. Because if they did not, then something is wrong with our entire picture of how the universe began. Stay with me for the next few minutes, because what you are about to hear is not science fiction. It is happening right now, this week, and it is rewriting the first chapter of the universe in real time. For decades, cosmologists have trusted a framework called lambda CDM. It is the closest thing science has to a master blueprint for how the universe was built. It explains the Big Bang. It explains how gravity pulled gas into the first stars. It explains the faint microwave glow still drifting across space today, the leftover heat of creation itself. It has passed test after test after test. And one of its most basic predictions is simple. In the first billion years after the Big Bang, the universe should still be young and small and quiet. No monster galaxies, no giant black holes, just the early flickers of the very first stars, slowly, patiently coming together. Then the James Webb Space Telescope opened its golden eye on the sky, and the early universe did not look quiet at all. When Webb's first deep field images came back in the summer of 2022, astronomers were stunned by the sheer beauty of what they saw. Thousands of galaxies packed into a sliver of sky no wider than a grain of sand held at arm's length. But hidden among those galaxies were hundreds of strange little points of light. Small, faint, blazing red. Nobody had ever seen them before, because no telescope before Webb was powerful enough to catch them. Scientists gave them a plain, almost harmless name, little red dots. But within months, some of the most respected astrophysicists on the planet were using a very different phrase. They said Webb had broken cosmology. Here is why that phrase was not an exaggeration. When researchers measured the light coming from these little red dots, the numbers did not make sense. These objects were sitting in the universe's infancy, somewhere between 600 million and 1.6 billion years after the Big Bang. And yet the data suggested some of them were powered by black holes already millions, maybe hundreds of millions of times the mass of our Sunday black holes that, according to every model we had, simply did not have enough time to grow that big, that fast. Imagine finding a fully grown, centuries-old oak tree standing in a pot that was planted 2 weeks ago. That is what the little red dots looked like to the scientists studying them. By 2023, dozens of papers had piled up trying to explain these objects. Astronomers noticed they all shared strange fingerprints, a tiny compact size, an unusual V-shaped light signature, bright in ultraviolet, bright again in visible light, with a dip carved in between, and wide, smeared spectral lines suggesting gas whipping around a black hole at extreme speed. One influential 2023 study argued that if the mass estimates were correct, the sheer number and size of these black holes was simply incompatible with lambda CDM, the standard model of the universe itself. That is the moment the panic became real. Not a rumor, not a fringe theory. Some of the top minds in cosmology were asking out loud whether our map of the universe had a hole in it. But here is where real science shows its strength. Scientists did not panic and give up. They did what good scientists always do. They went looking for their own mistakes first. And in January of 2026, a team led by researcher Ruskov, publishing in Nature, found one, a big one. The thick clouds of gas surrounding these black holes were distorting the light signals astronomers used to weigh them, artificially stretching the readings and making the black holes look far heavier than they actually were. Once the team corrected for this effect, the estimated masses dropped by roughly a factor of 100 times smaller. Just like that, a huge portion of the panic evaporated. The little red dots were still strange, still unexpected, but no longer proof that the universe itself was broken. For a moment, it looked like order had been restored. Then, on August 12, 2026, everything changed again. A team led by Rohan Naidu at MIT published a new paper in Nature describing a single object unlike anything ever recorded in the history of astronomy. They call it MOM BH1, and they gave it a name that sounds almost like a warning: a black hole star. This object existed just 660 million years after the Big Bang. To put that in perspective, the universe today is 13.8 billion years old. Webb was staring at something that existed when the universe was younger than 5% of its current age. And that object was pumping out energy at a level 100 billion times brighter than any single star in the universe is physically capable of producing. There is a hard limit in physics called the Eddington limit. It is the maximum brightness a star can reach before the outward push of its own radiation would tear it apart faster than gravity could hold it together. No known star, no matter how massive, can exceed that limit by a factor of 100 billion. It is not a technicality, it is a wall. And MOM BH1 blew straight through it. So what is it really? When the MIT team studied its spectrum in extraordinary detail, they found something almost impossible to categorize. At the center sits a black hole roughly 100,000 times the mass of our Sun. Wrapped around it is a colossal cocoon of hydrogen gas, roughly the size of our entire solar system. The black hole is devouring that gas faster than physics says it should be able to, a state scientists call super-Eddington accretion, essentially eating past the speed limit. The glowing gas cocoon gives it the outward appearance of a star. It even has a warm, extended surface. But the sheer scale of energy pouring out of it cannot be explained by any known stellar process. Full stop. Astronomers measure something called the Balmer break to study objects like this, a specific dip in the light spectrum. In MOM BH1, that measurement came out at 7.7. No population of stars, in any combination, at any age, has ever been observed producing a Balmer break that strong. There is only one explanation the data supports. A black hole has to be the engine. The MIT team is calling this the first direct spectral proof of a black hole in a dense gas cocoon, feeding at an impossible rate in the dawn of the universe. And they believe this may finally explain what the little red dots actually are. Not universe-breaking monsters, but something almost as strange: black holes disguised as stars, possibly scattered by the hundreds across the earliest chapters of cosmic history. Think about what that actually means for a moment. Every star you have ever looked up at, every star that has ever been cataloged by any observatory on Earth, obeys that Eddington limit. It is not a soft guideline. It comes directly from the physics of radiation pressure fighting against gravity, and it is held up under every test astronomers have ever thrown at it. MOM BH1 does not bend that rule. It shatters it. By a factor so large, it is almost difficult to say out loud without sounding like science fiction. 100 billion times brighter than the limit allows. That is the kind of number that makes seasoned researchers go back and check their code 3 separate times before they dare put it in a paper. If you are finding this as unsettling as I did when I first read the paper, do me one favor right now. Hit that like button. It genuinely helps this story reach more people who need to hear it, and it tells me you want more of these deep dives into the edge of human knowledge. Now stay with me, because it gets even stranger. Exactly 1 week before that Nature paper, on August 5th, 2026, a completely different team, this time from the Harvard Center for Astrophysics, proposed something even more extraordinary. They argued that some little red dots are not black holes at all. They are living stars. Not stars like our Sunday stars, roughly 100,000 times more massive, violently pulsating, shedding shells of nitrogen-rich gas in the final chaotic moments before they collapse in on themselves and give birth to the universe's very first supermassive black holes. Scientists have a name for these theoretical giants: Population 3 supermassive stars. The first generation of stars ever to form, built from nothing but raw hydrogen and helium, before the universe had forged a single atom of any heavier element. For decades, this was pure theory, a mathematical possibility scribbled on chalkboards. Nobody had ever actually seen one. Until, possibly now. The Harvard model solves a puzzle the black hole explanation struggles with. Little red dots show a strange chemical signature, an unusually high ratio of nitrogen to oxygen that neither ordinary stars nor typical black holes should be able to produce. But the extreme internal furnace of a supermassive dying star can. It also naturally explains the V-shaped spectrum and the compact, point-like appearance. If the Harvard team is right, we are not simply watching black holes feed in the early universe. We are watching the actual birth of the first supermassive black holes, the same class of monster that now sits silently at the center of our own Milky Way. In their own words, this is not a guess that giant black hole seeds existed. This is watching it happen, live, across 13 billion years of cosmic distance. Think about the weight of that claim for a second. We are not talking about spotting a new type of star. We are talking about potentially witnessing the literal construction process of the giant black holes that anchor nearly every major galaxy in the observable universe, including our own. The kind of object that normally takes billions of years to grow, caught in the act, in real light, frozen at the exact moment of its birth. So, which theory is correct? A black hole wrapped in gas, or a dying supermassive star giving birth to one? The truth is, both teams admit the two ideas might not even be in competition. Different little red dots scattered across the sky could be different stages of the exact same story. Webb is already being redirected toward more of these objects right now, hunting for the higher resolution data needed to finally settle the question. Both teams have named it their next target. We may have an answer within months. Now step back for a second and take in the sheer scale of what just happened. We built a telescope powerful enough to look back to the first sliver of cosmic time. We pointed it at the deepest, oldest light we can access. And almost immediately, it handed us objects nobody predicted, nobody modeled, and nobody had a ready explanation for. Objects so strange that respected scientists quietly hoped the data was simply wrong. And when they checked, again and again, it wasn't. This is not a flaw in the mission. This is the mission working exactly as designed. Webb was never built to simply confirm what we already knew. It was built to find the cracks in our understanding and shove a flashlight through them. And this is far from an isolated case. In the same 4 years of operation, Webb has spotted possible black holes that may have formed directly from collapsing gas clouds, skipping the star phase entirely. It found a fully formed galaxy blazing just 280 million years after the Big Bang, when the universe was not even 2% of its current age. It discovered a young galaxy that, against every prediction, does not appear to be spinning. It caught a gamma-ray burst that lasted 7 hours, when these violent flashes are supposed to fade out in under a minute. It has found exoplanet atmospheres that break every existing model of how planets are supposed to form. It even spotted a brand new moon around Uranus, one so small that no instrument before Webb could ever have caught it. And now, quite possibly, it has captured the first direct evidence of a black hole disguised as a star, sitting at the very dawn of time. Notice the pattern here. It is not that Webb keeps finding things slightly outside our predictions. It is finding things wildly, almost impossibly outside them. And every single time, the scientific process follows the same arc. First, disbelief. Then a desperate hunt for a measurement error. Then, when no error is found, a reluctant, careful acceptance that reality is stranger than the model. Then new theories are built to fit the new evidence. Webb tests those theories. And sometimes they survive. And sometimes Webb breaks those too, and the whole cycle begins again. That is not science failing. That is science working at its absolute best. If you have made it this far, I want you to think about something. If this is the kind of story that makes you feel that small electric spark of genuine curiosity, subscribe to the channel right now and turn on notifications. Because these discoveries are not slowing down, they are accelerating. And I want you here for every single one of them, the moment they happen. Here is the part that should genuinely keep you up at night in the best possible way. James Webb is not close to finished. Engineers estimate it has enough fuel to keep operating for another 20 years or more. In 4 years, it has only glanced at a tiny sliver of the total sky, and that sliver alone produced hundreds of objects that strain or outright break our models. What happens when it stares longer? What happens when it revisits the same patches of sky and gathers even fainter, even more distant light? What happens when the next generation of ground-based giant telescopes comes online and starts following up on everything Webb has already found? If the last 4 years are any guide, the answer is simple. We are going to find more things that do not fit. More objects that make brilliant scientists sit down and quietly write a paper titled, "In effect, we really hope this is a mistake." And more often than not, it will not be a mistake. It will simply be the universe, ancient and vast and completely indifferent to our theories, showing us once again how much stranger it actually is than anything we imagined. The little red dots taught us that the infant universe is far more crowded and chaotic than our models predicted. MOM BH1 taught us that black holes in the earliest years of cosmic time can grow into monsters that push straight through the laws of physics as we understood them. And the supermassive star hypothesis suggests that the very first stars in existence may have been titans so enormous they defy easy description. Titans that may have seeded every single supermassive black hole in the universe, including the one anchoring our own galaxy right now, at this very moment, as you watch this video. The universe is stranger than we ever imagined, and James Webb is proving it, one impossible red dot at a time. Before you go, I need to ask you something. If this story genuinely shifted how you think about the universe, even a little, share it with one person who would find this as fascinating as you just did. It costs you 10 seconds, and it is the single biggest way this channel grows. And drop a comment below telling me this. Do you think MOM BH1 is a black hole wearing a disguise, or a dying star giving birth to one? I read every single comment, and I want to know what you think. Think about the sheer improbability of this moment in human history. For nearly all of our existence as a species, the deepest sky was simply a ceiling of unreachable lights. We named the stars, we told stories about them, but we could never actually ask them how they came to be. Now, for the first time, we have built something powerful enough to ask that question directly. And the sky is answering back with objects so strange that our best scientists are still arguing about what they are even looking at. That is not a small thing. That is arguably one of the most significant scientific moments of this century, unfolding in real time, one Nature paper at a time. Because right now, this week, this month, astronomers around the world are staring at light that left its source before the Earth even existed, asking questions that have no answers yet. Questions that could reshape everything we think we know about how it all began. You are alive at exactly the moment humanity finally has the tools to witness it. Do not look away. Subscribe, stay close, because the next discovery might be even stranger than this one, and I will be right here to break it down for you the moment it happens.